Hello students, welcome to the class. In the last class, as we are dealing about the Helmholtz galvanometer, so I gave the principle, construction and the working of the Helmholtz galvanometer, isn't it? So as we saw, the Helmholtz galvanometer consists of the two circular coils. So these are the two circular coils which are having the same radius. So the first coil is also having a radius and the second coil is also having a radius, and both the coils are separated with a certain distance, and that distance also should be equal to the the radius of any one coil, that is equal to a. So this is what the thing. Now we are placing the needle at the center of the two circular coils joining, isn't it? So this is the needle we kept exactly at the center between these two circular coils. So as the distance between two circular coils is equal to a, so the distance of the needle from any one circular coil is equal to x I had taken. So it must be equal to the half of the distance, so nothing but a divided by 2. So already we saw this one in the last video. Now we are having the theory of the Helmholtz galvanometer. So in the theory we are going to prove the needle distance, that is x, is equal to a divided by 2, because it is half of the distance between these two. So x is equal to what? A divided by 2. So that we are going to prove in the today's class. Now I will go to the thing. So as we having the theory of the Helmholtz galvanometer, so first I will take the magnetic field, because as I said in the last class, whenever the current is passing through any circular coil, it is producing the magnetic field. So when it is produces the magnetic field, the needle will show the deflection according to the magnetic field. So now I will write the equation of the magnetic field that we studied in the last classes. So that nothing but the magnetic field along the axis of a circular coil, or you can take along the axis of, here two circular coils are there, so along the axis of two circular coils is, we can give, due to only one circular coil, I will write the equation, that is B is equal to, so mu naught Ni a square. So a is the the radius of that coil, mu naught Ni a square divided by 2a square plus x square raised to 3 by 2. So this is the equation. So this is the magnetic field due to one circular coil along the axis of that. So that is B, nothing but here you see. This is the axis, the line joining the center of these two. So here at any point, if you take the magnetic field we are calculating. So first I taken the magnetic field at here, which is at a distance of x, isn't it? And having the radius of that coil is equal to a. So for that I wrote the equation B is equal to mu naught Ni a square divided by 2a square plus x square raised to 3 by 2. Okay, and also we had in the last class is when we move away from the first circular coil, of course the magnetic field goes on decreases and decreases, isn't it? Because it is inversely proportional to the distance. So as we move away from the circular coil, the magnetic field decreases. So due to this C1 coil, due to this it decreases. But at the same time, now this point is nearer to the is nearer to the second coil, that is C2. So the magnetic field goes on increases. So what I want to say is, so whenever the magnetic field decreases due to one coil, at the same time it goes on increases due to another coil, isn't it? So how much decrease, that much will be increased. So how much decrease, that much will be increased. That's why at any point, if you take the addition of these two magnetic field, means this is also producing the magnetic field, let it be B1, and this is also producing the magnetic field, that is a B2. So B1 decreases due to this, means B2 will be what? Increases. So that's why at any point if you calculated that addition, means the total magnetic field which is equal to B1 plus B2, it will be what? Uniform. So it will be what? Uniform throughout this area, that is O1 to O2. So uniform magnetic field we are getting. So can I write that whatever the B value we wrote, it is equal to what? Uniform. So this is the uniform magnetic field had been created between O1 and O2. So now if it is the case, then if I differentiate the magnetic field with respect to the distance, so what I would have get, that is dB divided by dx. If I make so what we will get, which is equal to constant, isn't it? So when we divide the uniform magnetic field with respect to the distance, so at every point the division will be what? Same. For a dividing points, it will be what? Same quantity we are getting. That's why I am writing dB by dx. This differentiation should be equal to what? Constant. So if it is the case, again I will do the differentiation of this one. So when I will do the differentiation of this one, so what we will get? We are getting d square b by dx square is equal to the differentiation of constant quantity, as you know, which is giving a what? 0 value. This is giving the what? 0 value, isn't it? So now I will take this one as the first equation, the b value. So now our job is to differentiate this one in 2 times. So first differentiation do, you will get dB by dx, which is a constant quantity, and again if you differentiate this, it will get what? 0 quantity. So first, in the first step I will do the differentiation of this one in the first step. So what I will get? I will get, as we know, dB divided by dx is equal to, so differentiation of this one is nothing but constant quantity. I will write as it is, that is mu naught Ni a square divided by 2. It is a constant quantity. So what is remaining? Divided by a square plus x square raised to 3 by 2 is remaining. So if you take upper side, it will be minus 3 by 2, means I will write like this one. This is equal to mu naught Ni a square divided by 2 into, so I am taking it to the numerator. So when I will take numerator, this is become a square plus x square raised to minus 3 by 2, isn't it? Minus 3 by 2 we are getting. Now we are doing this differentiation. So mu naught Ni a square divided by 2 I wrote as it is. So a square plus x square raised to minus 3 by 2. So if you do the differentiation, you will get x raised to n, nothing but n into x raised to n minus 1. So like that, what we will get? N into, means minus 3 by 2 into a square plus x square raised to minus 3 by 2 minus 1, isn't it? So n minus 1 into, as we know, chain rule will apply here. So x square, again we should do the differentiation, into x square differentiation will be 2x. So I wrote like this, isn't it? Now this is equal to, here 2 get cancelled both the side. So what will be remaining? I will take minus 3 outside. So minus 3 if I take outside, minus 3 by 2 will be, this 2 will be as it is, minus 3 by 2 mu naught n square into the bracket. So a square plus x square raised to minus 3 by 2 minus 1. So giving the how much quantity? Minus 5 by 2 it will give. So that is a square plus x square raised to minus 5 divided by 2. Into x will be as it is. So x I wrote as it is. So this is the value of dB divided by dx. So differentiation of b. Now again next job is what? Again one more time we should differentiate, that is d square b by dx square value we will get, and which should be equal to what? 0, because it is a constant quantity. Why it is constant? Because it is uniform, isn't it? So now again I am differentiating this one. So if I do the differentiation again one more time with respect to x, so what I will get? I will get a d square b by dx square is equal to, again this is a constant quantity, I will write as it is, that is minus 3 by 2 mu naught Ni a square I wrote, and this is like u into v, isn't it? This is the u term and this is the v term. So u as it is, that is x square plus x square raised to minus 5 by 2 into differentiation of v. So x differentiation with respect to x is giving how much value? 1 value it will give, and plus, now this x phi will be as it is. Differentiation of you should make. So u differentiation will be what? Yeah, minus 5 by 2 into a square plus x square raised to minus 5 by 2 minus 1, n minus 1, and again into chain rule again we will apply. So that is x square will be 2x and this x will be as it is. So I wrote as it is, isn't it? So differentiation of u, this is, into v will be as it is. So I wrote the thing. Now then solve this one. So what we will get? Minus 3 by 2 mu naught ni a square into bracket, this is multiplying with 1 means same quantity we will get, and here little bit change I will make, just rearrangement. Okay, so this a square plus x square is to minus 5 by 2 is there. Yeah, I will write as it is now, minus 5 by 2, and this is will be again 2 get cancelled here, minus 5, this x into x becomes x square into the bracket, what we will get? A square plus x square raised to minus 5 by 2 minus 1 is giving how much value? Minus 7 by 2. It is giving the value. Now this is equal to minus 3 by 2 mu naught ni a square. So now I will do the rearrangement. As it is minus 7 by 2, it is minus 5 by 2. So I want to take minus 7 by 2 outside. So to take this, I will write this minus raised to minus 5 by 2 like this. That is a square plus x square raised to minus 7 by 2 into a square plus x square raised to 1, means minus 7 by 2 plus 1. If it is multiplying, plus 1 we will get. So what we will get? Minus 5 by 2. So this one I wrote in this form, isn't it? A square plus x square raised to minus 7 by 2 into a square plus x square raised to 1 I am getting, isn't it? And the next term I will keep as it is. That is minus 5 by x square into bracket a square plus x square raised to minus 7 by 2. Is it? So now easily we can take the common quantity, that is a square plus x square raised to minus 7 by 2, isn't it? So if you take outside, what you will get? Minus 3 by 2 mu naught ni a square, and this will be common. So I take outside. So what we will get? A square plus x square raised to minus 7 by 2. I taken a common. So what will be remaining? This will be remaining. That is a square plus x square, and here this went outside. So what will be remaining? Minus 5 x square will be remaining, isn't it? And as we saw first starting, that is if you differentiate one time you are getting constant, means this is a constant quantity. And if you differentiate again, it will be what? 0, because it is constant. So can I take d square b by dx square is equal to 0 here? So I taken 0. Now I will transfer all these terms to this side, isn't it? So when I will transfer these all terms to this side, again it become what? 0. Means lastly what we will get? We are getting this is equal to what? 0. Means what will be this quantity? This is a square plus x square minus 5x square becomes how much? Minus 4x square, which is equal to 0. Directly we can write, isn't it? Because that all the terms we transfer this side. So if it is the case, what we will get? We will get 4x square is equal to a square. Transfer minus 4x square this side, so you will get positive. That is 4x square is equal to what? A square, means x square is equal to a square divided by 4, isn't it? And on squaring both the side, what you would get? You are getting x is equal to a divided by 2, isn't it? So this is our solution. That is, as I told earlier, the needle should be half of the distance between these two. What is this distance? A, because which is equal to the radius, isn't it? So it should be what? Half of the distance, isn't it? So that's why we got by proving also, that is x is equal to a divided by 2. That meaning is the needle position should be exactly at the half of the distance between the what? These two coils. So this is what the first thing we got in the theory, isn't it? And the next, from this I want to prove how much current will be passing through the coil. How much current will be passing. So this one I am proving by using the what? Tangent law. So already we studied about the tangent law. So as according to the tangent law, we are having, according to the tangent law, we are having the equation B is equal to BH into tan theta. So this is the B magnetic field what we created. BH is the horizontal magnetic field and theta will be the angle in which the needle will be what? Suspended. So this is the what thing. Now here whatever the total magnetic field we are proving, here the magnetic field in the Helmholtz galvanometer what we created, it is due to two coils instead of one coil, isn't it? So one coil is producing the magnetic field is equal to how much? So let it be B1 is equal to how much it is producing? Mu naught Ni A square divided by 2A square plus X square raised to 3 by 2 at the needle, isn't it? So this is the one coil producing the magnetic field. In the same way, the another coil also produces the same magnetic field, that is B2. So now the total magnetic field is nothing but, is it B1 plus B2? Isn't it? So which is equal to, so B1 is also same, B2 is also same. So when we are adding both, we are getting 2 times of this one, isn't it? So that is 2 into mu naught Ni A square divided by 2A square plus X square raised to what? 3 by 2, isn't it? And here 2 get cancelled. So what we will get the final equation? That is mu naught Ni A square divided by A square plus X square raised to 3 by 2. This is the quantity we have, isn't it? And just before we proved one thing, that is the X value in terms of A. So the needle position means the X value should be at the half of the what? The radius, means is it X is equal to A divided by 2. So now I will substitute in this equation, X is equal to A divided by 2. So if I substitute in the equation, what I would have get? I would have get B is equal to mu naught Ni A square will be as it is into the divided by A square plus X value is what? A by 2. So X square means A square by 4 raised to 3 by 2. I am getting, isn't it? So which is equal to Ni A square divided by, so this becomes what? 4 will go here. So 4 plus 1, 5. So 5 A square by 4 raised to what? 3 by 2. Here you take the LCM, you will come to know, isn't it? So 4 will be the LCM. So 4 here will come, 4A square plus A square becomes 5A square divided by 4 raised to what? 3 by 2 we are getting. Now this is equal to mu naught Ni A square divided by, so raised to 3 by 2 means what? This we will get 3 times square root, isn't it? So 3 times when we will do means the square root of 5A square divided by 4 square and 5A square by 4. So shall I write like this, isn't it? So 3 times it will come. So raised to cube means 2 plus 1 becomes a 3 square root. So nothing but 5A square by 4 raised to 3 by 2 we are getting, which is equal to mu naught Ni A square divided by, so this will come outside. I am making this one easier term, isn't it? So to make easy, I splitted. Raised to 3 is there. So raised to 2 into raised to 1. So nothing but raised to 3 will get, and 1 by 2 means square root I am getting. So I will take this term outside. So N I will take outside. It becomes what? 5A square by 4, because 1 by 2 and this square will get cancelled. And what will be remaining? The remaining term is a square root of 5A square by 4 will be remaining, isn't it? So this is equal to mu naught Ni A square whole divided by, so A square by 4 will come outside. So A square will come it as what? A, isn't it? 5A square into A. This divided by 4 will be as it is 4. When it will come outside, it will be divided by 2, isn't it? So 2. Now what will be remaining? Square root of 5 only will be remaining. So that is what you are getting, mu naught Ni A square divided by, so A square A cube. Here this A square get cancelled, and 4 into 2, 8 will go to the what? Numerator. So 8 will be there, and this is 5 square root of 5, and a will be as it is, isn't it? Sorry, this a square is cancelled, isn't it? So we got the total magnetic field is equal to what? 8 mu naught Ni divided by 5 square root of 5a, because a square get cancelled. So this is B is equal to, we got, and according to tangent law we know B is equal to BH into tan theta, means this should be equal to what? BH tan theta. Is it the thing? BH tan theta we got. Now we are proving the current value. We are finding the current value. So I should transfer all those things to this side. So what I would have get? I would have get I is equal to, this will go 5 square root of 5a BH whole divided by, this will come to the denominator term, that is 8 mu naught N into what? Tan theta. So into tan theta we got. Now this is equal to, this whole term I will write it as K to compact the term. So I is equal to what? K into tan theta, is it? So the current is equal to how much? K into tan theta, where K value is how much? K value is 5 square root of 5 into A into BH divided by 8 mu naught into N. So this is the what? K value. So like that we proved the what? The current passing through the what? Helmholtz galvanometer. So when the current is passing in the Helmholtz galvanometer, that value should be equal to what? K into tan theta. This is the angle in which it is suspended. So like this is nothing but the what? The theory of the Helmholtz galvanometer, isn't it? So while writing the theory of the Helmholtz galvanometer, first you tell the magnetic field due to one coil is equal to, at a distance x, is equal to what? Mu naught Ni a square divided by 2 into bracket a square plus x square raised to 3 by 2, where a is the radius of that coil and x is the distance where we are finding the magnetic field. And for Helmholtz galvanometer, as we studied, due to both the coils, the in between that the magnetic field will be what? Uniform. So this is equal to uniform we got. Now a square plus x square is 2, you take to numerator, so it becomes what? Minus 3 by 2 we are getting. And as it is a uniform, so when we will divide it will be constant, again when we will divide it will be 0. So this B value first you differentiate, you will get the term this one, isn't it? So just solving a things you will come to know this one, and again when you will differentiate you will get the terms. So here one thing you should apply, u into phi rule you will apply, isn't it? So when you will apply u into phi, you will get this one. Then to take common term as minus 7 by 2, you rearrange this term raised to minus 5 by 2, like raised to minus 7 by 2 into raised to 1, isn't it? So now take common outside, as it is equal to 0, you will get a square minus 4x square is equal to 0. So x square is equal to a square by 4. That implies x is equal to a by 2. Means the needle should be at the exactly at the what? Half of the distance between those two, because it is creating the uniform magnetic field due to both the coils. This is the first part of the theory. And the second part, as we know, according to tangent law, B is equal to BH into tan theta. Because in this principle, on this principle only the Helmholtz galvanometer will be what? Working. But as we studied, the total magnetic field is here due to both the coils we should take. Due to one coil this is, and due to another coil the same thing we would have get, isn't it? Now that's what B is equal to B1 plus B2 means this again plus this means 2 times we will get. So 2 get cancelled, you are getting the quantity. And as just before we proved, x value should be equal to what? A divided by 2. So substituting the thing and rearranging the things like this, you will get this value. This is the B value, which should be equal to BH into tan theta. And as we are finding the I value, transferring all those terms, we are getting I is equal to this one, and this term we wrote like K. So I is equal to K into tan theta we got. This is the K value, which is a constant quantity. So because A is constant, BH value is constant, mu naught is constant, and number of turns, how much we are taking, will be constant. So this is the constant quantity. We got current is equal to K into what? Tan theta, isn't it? So this is what the theory of the Helmholtz galvanometer. Okay. So I hope you understood the principle, construction, working, and also the both the theories, that is x is equal to a by 2 and I is equal to k into tan theta. So if you studied this much, no, so for the exam 10 marks they will ask the question, explain the Helmholtz galvanometer with the construction, working and theory. So that time you should tell these all the things in a what? Brief manner. So practicing the thing you will come to know all the things, isn't it? Okay, thank you.